Okay, part 3, section 5.1 in college algebra. Let's wrap up this section with how to solve exponential equations. We're going to look at using the one-to-one property to solve exponential equations. Here is what the one-to-one property says. If you have some base a to the x power, and you set that equal to some base a to the y power, if those two bases are equal, then it follows that the two exponents must be equal. So when I have this situation right here, all I'm going to do is set the two exponents equal to each other and solve that resulting equation. For example, I've got 9 equal 3 to the x plus 1. Well, unfortunately, this one isn't in the perfect form where I have the same bases. But a lot of these, you're gonna have to rewrite it so you can make those two bases match. And once the bases match, you can just kind of wipe them off and set the two exponents equal to each other. Let's see how we can do that. I've got 9 equal 3 to the x plus 1. 3 is my base on this side, so I would like to see if I could rewrite 9 as 3 to a power, so I could have 3 to a power equal to 3 to a power, and I can use this one-to-one property. Well, I notice that 9 and 3 have something in common exponentially, which is 3 to the second power is the same thing as 9. So if I've got, or I should say, now I've got my two bases that are matching, so all I have to do is set my exponents equal to each other, like this, and very easily solve for x. So if I subtract my 1 on the other side, x is equal to 1. A very simple case of using the one-to-one property. So kind of think about your goal in working with these with the one-to-one property is to make the bases match. And once they match, you can just kind of drop them off and solve the resulting equation. So it's sort of like once the bases match, I just drop the 3's off and set 2 equal x plus 1. So here's a situation where I have a 1/2 to the x power equal to 8. Well, this one's a little more difficult, but let's try to rewrite it so I have a base of 2 on both sides. I'd like to have a base 2 to a power equal to a base 2 to a power. Now you may ask yourself, why did she choose base 2? Well, I'm noticing a 2 in here, and then I realize I can write 8 as 2 to a power. Well, I know 8 is 2 to the third power, so that one's not so bad. How can I rewrite a 1/2 to the x power as 2 to a power? Well, let's think about our exponents, and actually let's think about negative exponents. If I took that 1/2 and let's say I took its reciprocal. The reciprocal of 1/2 would be 2 over 1, which would be a 2. And if I took the reciprocal, that means that exponent changes a sign. I know this one's a little odd, but I want you to realize that in working with exponents, we can rewrite this 1/2 to the x as 2 to the negative x power. All right, dogs, quit. Go somewhere else and play. Sorry, guys. Go. Let's see if these guys can be quiet. So I was able to rewrite 1/2 to the x as a 2 to the negative x power, able to rewrite the 8 as 2 to the third power. Now that my bases match, I can set my exponents equal. So I get negative x equal to 3, and when I solve that for x, x is equal to negative 3. You could actually go and check your work, put a negative 3 back in place for x up here on your calculator. A 1/2 to the negative 3 power is equal to 8. This third one might be a little bit easier for you. Let's play the game of make the bases match. The base on the left side is 8. The base on the right side is 2. Is there any way to write 8 as a base of 2 to a power? Well, we just saw earlier 2 to the third power is equal to 8. So notice by doing that, both of my bases match. And when the bases match, the one-to-one property says the exponents must be equal. So again, when you get those bases to match, it's just sort of like cancel them out and solve the remaining equation. Well, I get 3 equal to 2x minus 1. So I would bring my 1 over. So I would add 1 and get 4 equal 2x. And dividing by 2 gives me x equal 2. Let's look at one more example. I wrote down example 4. I apologize for all the interruptions, but the dogs got to playing hard and one of them got hurt, and so now they're going to be quiet for a while. Let us get through this last example. Okay, I've got the equation e to the x squared equal e to the 9th power. It's an exponential equation, and notice how easy this one's going to be to work with to make the bases match, because ta-da, the bases already match. So yay, that part is done for us. When the bases match, remember, all we really kind of have to do is just sort of knock those two bases off and solve the resulting equation that comes from the exponents. Well, if I set x squared equal 9, that turns into Mr. Quadratic that we can solve. Actually, you probably don't want to bring the 9 over, so let's x that. And when I see x squared equal 9, I see I can use that square root property where I can square root both sides. And remember to put plus or minus on that 9. So I get x equal plus or minus 3 when I square root both sides. So this guy has two solutions, x equal 3, x equal negative 3. So you never really know where that quadratic is going to rear his ugly head. But we've done a lot of work with quadratics and we've done a lot of practice. Hopefully we recognize them now and recognize how to solve them. So this finishes up section 5.1. Let me know if you have any questions.